All right, welcome to chapter 13 that deals with disaster planning and recovery. You will have to bear with me on this particular chapter because I have 74 slides. I'm going to try and do the best to keep it as short as possible. But we do have two separate modules under this chapter. That's my contact information again, my certifications, copyright. So in this particular chapter, we're going to look at how do we take tools, how do we select tools for automation and IT service management, and then we'll end up by looking at business continuity, like through what's called resilient design. For the IT service management, there is another certification called ITIL, ITIL, which I also have, and I do teach that course. My concept is I don't teach any course unless I'm certified in that one or higher, or at least I've taken the exam and passed. That way I can at least tell you what the contents of the exams are. It kind of brings credibility. And some organizations actually insist on that, right? So this is a combination. But in module A, we're looking at secure operations. So we look at orchestration, automation, how do we incorporate cybersecurity into change management, and then two other very important principles, which is configuration management and patch management. So what's the difference between automation and orchestration? Because sometimes you hear people talking about it and there's a confusion. Basically, automation has to do with how do you complete a particular task, like a single task, whether it's simple or complex, without human intervention. And then orchestration is really more like a several automation, or better said, automating tasks, put them into a sequence for like a process or workflow. So you hear people say automation, like orchestration is basically automation for processes rather than tasks. But just think about it as involving more than one. So in this slide, we talk about scripting. What you really need to know here is there are some scripting languages that are platform or operating system specific, and other ones are platform agnostic. So you see on there like Python, PowerShell, which one is for Windows, which one is for Linux, or Ruby, and then JavaScript for client-side automation. But the benefit of automation is basically, some tasks are repetitive and boring. So automation kind of helps your workflow, helps you take care of those things. And it says you now take fewer people to perform more work. There's consistency and speed because a script can execute most commands faster than you and I as humans can do that. There are different technologies for security automation. Nowadays, AI is helping us through machine learning. Of course, the heuristic detection of like malware, AI helps us a lot. You have this thing called SOAR, which is a security orchestration, automation, and response. They complement the SIEM we talked about before, the logging approach to help us identify and respond to common incidents. So automation, they're very, very important for security, processing security related data. Now, since automated security response, these systems can respond 24/7. You and I cannot be up 24/7. They help us with real-time notification and tracking, even escalation. If you automate it properly, we know somebody's skill set and another person's skill set. So if it thinks, say, analyst A cannot handle it, it can automatically escalate it to analyst B. You can design this very well or configure it in such a good way that you get better response time, customizable and scalable workflows are part of the benefits on there. For resource provisioning, this section just wants you to remember these four concepts. Network provisioning, network resources, making sure they are available, server provisioning, setting up servers, user provisioning, how do I create, maintain user accounts and the attributes associated to those users, and of course, how do I get rid of like offboarding, which is really deprovisioning, right? Freeing up the resources that I have already allocated or previously allocated or provisioned. In software development, we touched on this in chapter 12 a little. When we talk about secured coding practices, I mentioned it briefly in the video, so please reference that. But in automated software development, you have these 5 principles: continuous integration, continuous delivery, continuous deployment, continuous validation, continuous monitoring. But while these things have benefit, there's also risk inherent in them, because just like a normal system can fail, automated system can also fail, maybe because of maybe malfunctions or there's misconfiguration. And then also the issues about a single point of failure or single point of attack, you want to look at it that way. That's what centralized automation platforms can also do. And of course, there's cost, there's complexity, there's also risk associated with it. But it's just telling you this is a very good concept in tech, especially cybersecurity, what's called a technical debt, DEBT. If you choose a cheap or easy solution in the short term, you're going to have what's called a technical debt, which means you got to pay it back later with additional effort. So be careful. There's in, like, say, some street language, you say cheap item upsets your stomach. Pidgin English, you say cheap article, they run belly. Technology integration, you have stuff like API, application programming interface. I also talked about it in the previous chapter. For communication, it's like an interface used for input and output with other applications. So you have Linux One, which is the POSIX, and then you have other ones. But just understand that you have ways to integrate technology in here. But with all this issue about automation, orchestration, it's good to have guardrails, things to help guard against problems. So you have policies, procedures, and technical controls to help reduce the likelihood or impact if something were to go wrong. So this could be least privilege principles, error detection, throttling, as in slowing down, and resource limits, logging and monitoring, testing, and version control, and definitely documentation and training, guardrails that we can put. So back on the IT service management that I mentioned at the beginning, as it relates to the ITIL certification, you have this concept about change management, asset management, configuration management, and patch management. Of course, change is just having a organized process to track changes, right? And asset management, accounting for everything you have in the organization, configuration, identify, manage, configurable system components, and of course, patch management. If I have fixes that are released by manufacturers or the application developer, the company, how do I put it in my system? How do I now install that software to fix, or as it says, remediate a vulnerability? So I need a good patch management process, because sometimes you can fix a problem and it introduces other problems. So have a systematic process. So for change management, you have identify, change request, approval, preparation, implementation, and then a follow-up, which could also mean continuous improvement, continuous monitoring. This would be like 6. Sometimes you might see this divided up into like 5 steps. But it says number 1 is identification. How do I identify the change? I need to figure out the options, correcting any kind of problem. Will it fix the problem? Ask myself this kind of questions. Will it introduce compatibility issues? What users, systems are affected? So seek advice from colleagues or technical support resources to verify your decision. Right? So identifying the changes basically means validate that there's an existing or a developing problem that needs to be addressed. Because if it ain't broken, don't fix it, right? How do you request change? There's a process, right? So sending potential concerns and answers. What information about the change itself, purpose, scope, the potential impact of the change? So it could be short-term, long-term benefits. Have a timetable or operational method, and definitely have a backout plan in case of unforeseen problems that come up during or after the change. It means, how do I go back to the previous state because I have a problem now? Sometimes you need to do impact analysis, study the system state and how on interrelated parts they fit together. Have some kind of metrics to measure positive and negative impacts of the change that you want to do. What are the steps? You need to do risk analysis and a cost-benefit analysis based on the results to try and prioritize your risk. And then definitely develop a mitigation plan for identify risk, right? So just make sure that you are well prepared. That's part of performing your impact analysis. And then you need to prepare for the change, maybe purchase or prepare any resources you need. Prepare properly for the change. Immediately before the change, make backups. And then how do you test and how do you implement the change? Like what we call rolling updates. That could be what I call a hello hanging fruit question on the exam. I mean, if you have like redundant systems, maybe it says relatively independent nodes in a cluster, or you have what's called the blue-green updates, which is like using two independent environments like the test and production. And you have what's called canary testing. So you like rolling out a change, rolling out a change out to independent systems for testing and validation, and you're expanding or rolling back based on the results. So like a slow process. All right, maintenance windows, obviously make sure you have ample time to apply your update and restart the systems. Make sure that you have your maintenance in place. Define the windows, maintenance windows for the different systems. And of course, finalize your change, such as test the result, notify the users and administrators after you've done that, continue a review process for as long as required, and definitely update your documentation to reflect the new state of the system. Back to asset management or inventory management. We always say every system administrator needs to know every single device on their network. Hardware, servers, workstation, mobile devices, storage. You need to document them. Even software, operating system, the applications, and definitely even your virtual assets, your VM, certificates, cloud services, domain name, and IP addresses. You need to document them. That's part of inventory management. So in configuration management, it's just a physical and logical diagram of your network. You see logical diagrams. You hear people say physical is like maybe how they are connected. Logical could be like assigned IP addresses. And even MAC addresses needs to be documented. How did you assign IP address? So this might seem a little boring or too, I don't want to use the word academic or something, but if you know like a tool like Nmap, you know that if somebody maps your system and sees a range of IP address, you don't know what they can do with the other ones. So just figure out what IP addresses are assigned, and of course know your internal operating process, and then have your baseline of network usage patterns. So if you see an unusual pattern, you know this doesn't seem right. Why am I having so much bandwidth at 4 a.m. in the morning, or why am I having so much usage of or CPU processing? Know your configuration, of course, government regulation and vulnerabilities in your system and what you need to do to take care of them. This is like a simple diagram of a configuration management. Like you have a database, like central repository for all configurable items. This is pretty straightforward, but version control. So this helps me to track revisions to my files or set of files. You get a word called source control, revision control, or source code management. This could also be manual. If it's manual, it just means I'm putting maybe a version code at the end of each file and storing them maybe some kind of method. But this is not always scalable, and you could have problems with errors. So it is better to have a dedicated version control software like a Git, as you heard of GitHub, or concurrent version, or Apache Subversion for version control. That way I can know when I can go back to a previous version or what happened in a new version. Because sometimes you have a new version and it introduces problems. You need to be able to know how to go back to it, right? All right, so patch management. We always say update, update, update. You'll be amazed at how many security breaches that happen because people didn't patch the software, and the manufacturer has already released an update and it was not installed. So I know in an enterprise environment, it's not as simple as, say, in a small office, home office on your phone, but you need to have a patch management process, right? So fortunately, as it says on here, many organizations don't take patching of updates seriously. So you must make it a high priority, especially after the discovery of a new critical vulnerability, because when you see all those CVE numbers, the bad guys also read CVE numbers. So when I map your system and I see you using Apache also using a Windows 7 or Windows 10, I'm going to try and get a cheap malware to attack your system. How do we plan for this? You should make an inventory of all your systems and your software. Even if it's an isolated network, don't ignore that. Have your policies. Test your updates before you deploy them. I think it was CrowdStrike that you said that the update was not properly tested before it was deployed. And of course, you know how the supply chain issue, right? Document all your patches. Update your security baseline, your system images, and other documentation. Good discussion on software updates. Why is it important to test it before you deploy it in production? And why is patch management important? All right, a few assessment questions. What is the primary purpose of using guardrails in IT automation? Best answer. This one is streamlined to reduce the risk of accidental misuse of automated process. Next one. What automation practice keeps code created by multiple developers from diverging or conflicting? Choose the best one, right? So if I'm continuously integrating them, it's going to be less likely that they're going to diverge. All right, so in a software change management process, which practice is primarily designed to make backout plans more reliable? If I don't know which version I'm working on and the previous version, how am I going to know to back out to go back to the previous version? So version control does this for me. Which of the following is not a good advice for planning maintenance windows? So this one is like, think about it. Use a single maintenance window for all your systems in enterprise rather than staggering them. That is dangerous. So that's not a good advice, right? Use multiple ones. Which of the following script, yeah, this is a good question. Which of the following script file extensions are not specific to Linux or Windows? Choose all that apply. So think about it this way. When I was on that slide, I was saying you don't necessarily need to know all types of scripting language, but you should have an idea which ones are specific to a particular operating system. And it's easy here because we know that I can use Python in any system, right? Good. I can use Ruby in any system, that's C and D. But .bat, .sh, of course, that's shell, PowerShell, and .bat, right? That gives away those other three. So maybe it's good to know the extension. But just know that Python, Ruby, some of those other scripting languages, the term is platform agnostics. All right, so let's get to module B, which is how do you plan for business continuity and disaster recovery, excuse me. How do you deploy resilient systems and sound backup policies and procedure? That's a good exam question. All right, so for business continuity in general, planning for it, you hear the word BCP, BIA, you hear DRP. Sometimes you now see BCDRP or DRBCP when they combine BCP and DR, right? Site risk assessment. How do I talk about information security contingency planning, and of course, continuity of operation plan, crisis communication plan, succession plan. Many of these are similar to other industries, not just in tech. So if you're watching this video from another place, this relates to that. You can watch this video and the concepts translate. Especially COOP and a BIA. You need to do BCP, DRP, BIA for anything. If you're working in a hurricane-prone zone, you need to think about this concept, right? All right, so in general, the process of creating a BCP mirrors that of other like risk management program, which is you perform a risk assessment, create a business impact. So sometimes BIA, you can hear people saying business impact assessment or business impact analysis, right? So the conventional ways that A should be analysis. So I create a BIA which feeds into the BCP or the DRP. Design the BCP and the supporting recovery plans and control, implement and test the plan, analyze the results to apply further refinement or continuous improvement. So again, that applies to other industries. So how do I create my business impact analysis? You want to look for this. So the classic definition for BIA is basically looking for critical business functions that are going to be affected by something happening to your organization, right? So identify your mission essential functions that are critical to sustain your business operations, those things that you need, otherwise you're going to be out of business. So identify the system resources or even the functions used by each of these critical functions. Because when you do that, you can now do number 3, which is to prioritize the critical functions according to what is called the maximum tolerable downtime. How long can you be down before you get to critical stage, or how quickly they must be restored to prevent severe damage to your business operation. And then you need to identify the threats that could compromise each of these business functions. And when you're not just doing that for academic exercise, you need to now figure out what are the mitigation techniques or strategies that you could use against each of those threats, right? So the BIA is very important. You need the BIA before you can do, backing up a little, before you can do your BCP or your DRP. All right, so similar in any other BCP or DRP, any kind of crisis situation, I need a communication plan. In project management, we have that portion. So internal communication should be quick and targeted to make sure that everybody, like say, the relevant stakeholders, are up to date for what they need in their particular department or the role, right? Of course, if you have other incident reporting regulations, like a breach regulation by the government, you must have a contact number, right, for replying to that specific requirement. Communicating with the external public, such as customers or the news media, is very, very important in any incident that, of course, might damage your reputation. We always say it's better to have one person as a point of contact, and you want to have like a unified message. You don't want everybody talking all kind of stuff. It's good to say, okay, the PRO or our crisis communication, the person, here's their number, call the person, so that they know the message is coming from one person, right? So if you are thinking about what's called a risk matrix, or sorry, a RACI matrix, we're thinking about who is responsible, accountable, consulted, informed, who is ultimately responsible for communicating of that crisis, dealing with the public. All right, so for disaster recovery plan, you need the documentation, vendor list, alternative practice, backup policies, how do we recover, restore, and of course, our emergency contact along with our personnel list. These are very important. So for both the business continuity and disaster recovery plan, we need to test them. A plan that is not tested is useless, right? So there are different ways to test the plans. You need to know this for the exam. Checklist tests, you give the plan to one or more people to review and examine item by item. Okay, go through a checklist. Tabletop exercise, pretty good. You gather around a table or a converging point, the team or the department to review the plan and walk through a theoretical disaster step by step. The simulated testing, you actually need to test the actual response under like controlled circumstances, maybe on a small or a larger scale. Sorry, tabletop exercise, you hear the people also call it a walkthrough, so remember that. Now, so that the last two are a little more involved. I choose what disruptive than the previous 3. The parallel test, you test the activation of an alternative site without interrupting operations like at the main site. So you're testing the alternative site in parallel with the regular production site. Then you have the full interruption test. This is major. It's like a parallel task, but operation at the primary site, they are actually halted or stopped. And then maybe see what the alternative site takes over. You just check to make sure you can handle it, right? So this is like how you get like a drill, active shooter drill or something. Some of the you stop everything you're doing and then you test it to see if it's going to work. There's always a good discussion about continuity planning. Is there a difference between DRP, BCP? Many organizations combine them together. They call it BCDRP or DRO, BCP, right? But either way, you remember that you need to have your BIA before you can continue to do that, right? But let me see here. Cybersecurity, resilience. You remember the CIA triad is all cybersecurity, sorry, all about the CIA triad. To have a resilient system, you need to think about high availability, fault tolerance, the quality of service, which what you prioritize over the other, and then of course scalability, and also disaster recovery in the case of a cyber breach or a cybersecurity incident. But here we need to talk about, as relates to cybersecurity specifically, there are two terms you need to be aware of. We already looked at the MTD, maximum tolerable downtime. So we now have two concepts: recovery time objective and then recovery point objective. The best way to think about these two is one has to do with the data. How much information can you afford to lose? So the RPO is the maximum period for which data will be lost in the case of a disaster. I got attacked at 10 a.m. today and I made a backup at 11 p.m. yesterday. So that's about, excuse my math, 11 hours, right? Can I tolerate that much loss of data? Whereas the RTO is the maximum downtime between when a service is taken offline, when you get that cyber attack, and when its function will be fully restored. How long? And look at this. I love this little diagram in here. So you can see RPO, like a system failure, and then you see the RTO extending on this diagram. There are other metrics in there that if you were to take like the CISSP or the CASP class, you need to know that stuff like WT or other metrics. But for now, just know these two terms. Right? RTO, RPO, and it's a testable material in the exam. So when you hear the word fault tolerance, basically means how resilient is the system. It's any technology system, whether it be a CPU cooler, will fail over time. If you just have one, it's a single point of failure. And you want to try and avoid that because that is an enemy of availability. So the simplest way to avoid this is to reinforce it by buying higher capacity. But the better one is fault tolerance, where maybe something that you believe that is critical, even if it fails, it doesn't hurt the system because you have a backup plan. One way to do this is using what I call redundancy strategies. Backup power generator, RAID arrays, and data replication. RAID arrays is assumed at this point you've taken A+ or Net+, or you are aware of RAID 0, RAID 1, which is mirroring, striping, and then you're aware of RAID 5 and RAID 10. So know those two. All right, let me explain. So RAID 0, where I write here, I write there. Yeah, it gives me performance, doesn't give me redundancy. RAID 1, where I mirror, right? It gives me redundancy, but it doesn't give me performance, right? It gives me fault tolerance. And then look at 5 and 10. 10 is a combination. But this is not a class on RAID, but just have an idea that it's part of a redundancy strategy. Network multiplication, load balancing, clustering, distributing or grid system virtualization technologies, vendor diversity. We're going to look at this in a minute. And then, of course, alternative sites. These are important concepts, right? For you to know. For power supply, you know, UPS. I find that some people in emerging countries know about UPS more than people in developed nations. Of course, generator, redundant power distribution, these are very, very important. Data centers need to have all of this because you cannot afford to be down, right? Platform diversity, this is kind of like interesting because it is supposedly part of defense in depth. So maybe I have multiple, I need to have multiple failures for my system to go down. So the adversary has to have a lot of failures, right? So it says vendor diversity can increase the resilience of like supply chain. I'm not just using a Cisco router, maybe I'm using a Juniper router. Also, cryptographic solutions are also part of platform diversity. Just think about it. Don't have one company, have more than one as an example. This I've seen before in an exam question about scalability strategies. They're asking you about vertical up-down scalability or horizontal scalability. And then, of course, you see the word elasticity. So scaling up or vertical just increases the capacity of that individual solution, right? So maybe replacing bottlenecks with more powerful components, whereas scaling out increases the capacity like via redundant systems or component. Maybe I increase the size of my pants, or I gain extra weight. Just know what each one stands for. And elasticity is always mentioned in terms of cloud computing. It's just the ability of an application to expand up and down as demand increases or decreases. So think about somebody wearing pants with an elastic waist, goes up and down as they increase weight or they lose weight. Okay, load balancing and clustering. Load balancing is very, very good for performance purposes, right? So what I do here is uh, you distribute incoming network traffic across multiple servers so that one is not overwhelmed and gives you better performance. And then you have what failover clusters. The whole idea is you have your redundancy and fault tolerance. You allow like multiple computing nodes to operate as a single entity. It's an important concept. Now, this one, you get exam questions all the time. Alternative processing sites. Mobile site just means your site is in a mobile form, like on a vehicle. If you see like a forensic station example is mobile. It just means uh, it can be hauled to another location, maybe on call it on wheels. But let's look at the top three here, meaning, right? Hot site is the exact duplicate. Is the best one for full fault tolerance, redundancy, but also is the most expensive one. So here you have your complete hardware, infrastructure, software, right? It's like a copy of your production environment. And then maybe sometimes it's staff that is necessary to keep them running. Of course, the cold side is the opposite of hot side. And then the warm side is like a middle point between the two. So you have this word called geographic dispersal. Most of the time you hear this as relates to cloud service provider. But if your organization is large, it's just telling you that you can spread your facilities over a large, wide geographic area by having maybe redundant services ready to take over for one another. In the case of AWS, Microsoft Azure, Google Cloud, they take advantage of this. So like you hear them having what's called geographic regions around the world, multiple availability zones in each of the region. Of course, some of this is for what's called data sovereignty compliance, but most of the time is to give you redundancy. I believe last month, AWS was down in US, so I couldn't post on Canvas for my students. Eventually came up, but of course, some of my students used it as an excuse to ask for extension. All right, for cloud redundancy, your cloud service providers, CSP, they offer redundancy and high availability features, right? This is good for you to also have cloud. You have cloud native resources, is very useful for this. But it's recommended you maintain multi-cloud deployment, which is like a vendor diversity that we mentioned 2 slides ago, right? Because these cloud deployments are not standard. So you must plan in advance even to the point of allocating resources that you might need in the cloud. Capacity planning, both for your infrastructure, your people, and your technology, just make sure you need more than you need. You need more than you need on a regular basis, I should say. Sorry, make sure you get more than you need on a regular basis. This video is getting too long. All right. Not all technology solutions are designed for the same amount of redundancy, scalability, or flexibility. Just be aware of that, right? You should always consider resiliency and scalability issues. So good discussion. How much fault tolerance do you have? How much do you need for good recovery? Right? Are you willing to pay for it? Backups. Know what the 3-2-1 rule recommended by US CERT, right? 3 copies, 2 different media, 1 in an offsite location. That's basically all the 3-2-1 backup rule means. Sometimes they might not ask the question that easy. They might give you a scenario and ask you, is this the implementation of what, right? All right, so for backups, speed, USB, removable hard drives are pretty good for individual computers. Magnetic tapes are awesome for long term. Optical media like DVD, CDs, they're really good for archiving because they don't have the moving parts like your hard disk drive. But we also have the network attached storage and storage area network. That's the SAN and NAS. Of course, cloud backup is also available for you, but it costs money. Very good exam question here, especially the top 3. Backup types. It confuses people. The lower one, image, is just a full backup of all your system volume. You can restore the system in full operation for just a bare metal state. Of course, snapshot is like a picture of your system at a particular point in time. It says type of backup used to quickly capture a system's point in time state with limited impact on ongoing operations. But you're going to see more questions on full incremental and differential backups. Of course, full is easy. You back up everything. Maybe the trick might be you clear the archive bits for all of your files because you've archived them, right? Incremental, you back up only files with a set archive bit, then you clear the bit. And of course, differential backs up only files with a set archive bit. So the increment and differential is what confuses people. So let's distinguish it for a minute. So think about it is, I backed up my files on Sunday. And on Monday, I make some changes. So on Monday, the change between Sunday and Monday is a portion, right? So I am going to now back up what changed on Monday. What happens if I get some changes on Tuesday? So I can either back up everything from that changed between Sunday and Tuesday, or back up what changed between Monday and Tuesday. So you see, if I back up what changed on Tuesday and what changed on Monday, I have 3 backup devices. So that's going to affect how I roll back. So you get a question about which one is faster. So I can replicate my storage with synchronous replication or asynchronous replication. This is pretty much straightforward, right? Remote journaling for database. I just have it's like an incremental backup. Log of recent transactions to remote side, and of course you have remote mirroring. So these are database backups. For backup security, transport them securely. You should actually encrypt your backup. Use the same security you use with original files. Securely erase and destroy them like you do any other files, right? All right, you should have backup policies for your organization. Schedule your backup when you're going to do that. Make sure you keep it secure. Again, assign personnel responsibility, even access rights. All right, there's a lab for scheduling a server backup. I'm going to explain more with an exam question here on incremental and differential. So business continuity. What document specifically covers moving operations to a temporary site? What do you think that would be? That's going to be your COOP. What is also known as structured walkthrough? I mentioned that already, right? I kind of gave it to you before. Tabletop exercise. Fault tolerance and recovery. So here, I love this question. Recovery plan for that service here. So you see this service, it has a low recovery point objective because you're doing it all the time. But it has a high recovery time objective. That's why C is here, because I'm backing them all the time, right? So it's a low RPO. All right, so look at this one, fault tolerance and recovery. If you have all necessary hardware, network connectivity, and production environment, all you have to do is send everything to the incoming site. That means it's a hot site. Duplicate. All right, this one here, in terms of how does a differential backup plan generally differ from an incremental backup plan? Good question here. Okay, so look here. Differential, it is slower to create the backups because I'm backing up all the difference from the backup or a full backup to that particular day, so I have more, right? But it's quicker to restore the backup because I will only need fewer data media. Okay. Sorry. So this is the video for the. Let's go back here. This is the video. Let me go back up. Sorry, the system. This is the video for the next one. I don't. If I click on here, it plays it, but you will see it on here. I'll show you briefly before I go off. And of course, summary here. You should know how to practice secure IT operations using that. Create business continuity plan. If you have any questions, send them to me. Let me stop sending this. I can also help you with some test questions. So let me show you the other video that I recommend that you go and see if you want to look up on the slide here. Let me go back quickly to that slide there. But one way to practice for this exam, I tell people, is to think about.
Was rather implied, doesn't it? Especially to the critics of the Trump administration, that there's an uncomfortably.
Let me pull up this for you without wasting up. Just ask me, send me an email and ask for or just search on the YouTube channel. But when you see the video, it will look like this. That's how the video looks like. It says incident response and contingency planning. All right. So not to take up more of the time. This video has gone really long. Again, I wish you good luck on the exam. We only have one more chapter left. If you are a student at the university, I have another chapter on AI and cybersecurity. That will be week 15 lecture. So week 14 will come up maybe tomorrow. So good.